Static electricity. Let's go. Coulomb's law. Now, in Coulomb's law, it says that the force is directly proportional to the product of the two charges separated by the square of the distance apart. Now, if we remove the proportionality sign, we introduce a constant K. And the constant is, you can see the value of the constant here is 9 times 10 to the power of 9 Newton meter square per Coulomb square. Now, this K represents 1/4 pi epsilon naught. Now, this epsilon naught, some can call it the permittivity of free space. This is the value 8 times 8, 5 times 10 to the power of minus 12. If you know this formula, remember this is the introduction. We'll be doing a lot of things in this topic. Let's go. We have example number 1 at the board. An electron is at a distance of 5.0 times 10 to the power of minus 11 meters away from the center of a proton. Calculate the electrostatic force on it. Now you have the charge of an electron, which is 1.6 times 10 to the power of minus 9. Please note that we have a plus here, we have a minus here. It doesn't actually matter under the Coulomb's law. It's just trying to tell you that the electron is negatively charged and the proton is what? Positively charged. That's all. Now, they want to calculate the electrostatic force. Now, having our formula that F is equals to K, Q1, Q2 all over R squared. Now, all you need to do is insert your values. So, F is equals to 9 times 10 to the power of 9 times, they are 2. So, I will just say 1.6 times 10 to the power of minus 19 all in square. Divided by the distance separating them. It's already in meters. Always remember that the distance must be in meters. So, you have 5.0 times 10 to the power of minus 11. Remember, all is in square. So all you need to do right now, you simply punch your calculator and you simply get your answer 9.2 times 10 to the power of minus 8. So you have an answer of 9.2 times 10 to the power of minus 8 newtons. That is it for that video. So what is the magnitude of electrostatic force between an alpha particle and an electron? And it's separated by this distance, you can see. So that means that the first quantity of charge is an alpha particle, the second one is an electron. And if you know your radioactivity very well, you will know that the alpha particle it has a mass number of 4 and it has an atomic number of 2. Now, this symbol represents the alpha particle. And remember, we said in a particle, you can see here in an atom, the number of proton is the same thing as the number of electron, and you can also call it the atomic number. That is in isotopes. We did it very well. So that means that the first one, which is the alpha particle, it have the number of electrons here is 2 electrons, and it's separated by a distance. Here we only have an electron here. So that means that your Q1 is 2 electrons and your Q2 is only a single electron. Please understand this thing very well. It's so simple. Now all you need to do is remember that the force is K, Q1, Q2 all over R squared. Now all you need to do right now is just simply you put it and your answer will flow naturally. So you have 9 times 10 to the power of 9 times your Q1 is 2E times your Q2 is E all over 1 times 10 to the power of minus 13 all in square. Now remember we have the 2 e's here. That means automatically 2e times e, we have 2e squared, right? So here will now give me F is 9 times 10 to the power of 9 times 2e squared all over 1 times 10 to the power of minus 13 squared. Now all you need to do right now is we just put, so this will now give you, instead of putting e squared here, let me remove it and represent it as 1.6 times 10 to the power of minus 19 squared I don't want to rewrite it again, it will waste my time. So if you punch this in your calculator, what you will simply get is 4.6 times 10 to the power minus 2. So you have here to be 4.6 times 10 to the power minus 2 Newton. So that is the answer. So be conversant with this. Under this static electricity, I will be doing videos on it, more than 50 something. Follow me on this channel, subscribe, share, like. Please always leave a comment for me so that it will motivate me to do more. Thank you very much.